Good morning, Year 6. I hope you're all safe and well. Today is the 2nd of July 2020, and today we are going to be solving problems involving scale factors. So pause the video, date and learning intention written down, and let's get started. You'll need your pencil, paper, thinking hat, both your logic hat and your method hat, and you will need the scale factor problems worksheets which were emailed to you this morning, but you can also find on our school website under online learning, Year 6, and you'll need a 5-minute timer. Make sure you've got all of those and we're ready to begin. For our arithmetic starter, it's similar to what we did yesterday, different set of questions but similar layout. I'd like you to pause the video here, set your 5-minute timer and have a go at answering the questions shown on screen. Excellent, now let's run through the answers. So 461.72 plus 49.8 equals 511.52. You had to make sure your decimals were lined up correctly when you used the written method. 56,187 minus 25,972 leaves us with 30,215. 72 times 45 equals 3,240. So you had to remember then when you multiplied, if you used the written method on your second row, you had to make sure that you had your 0 at the start there. You put a 0 there to start with because we're multiplying the tens. Number 4, 8,903 divided by 3 equals 2,967.66 recurring. Okay, so you only need to write your answer up to 2 decimal places. And it's 0.66 recurring. And number 5, 2/9 plus 1 1/3 equals, well, we need to make sure that they both have the same denominator and our mixed number is an improper fraction. So if we change them both into, make sure they're both in ninths, then 1 1/3 would actually become 12/9 because there are 9/9 in one whole, and then 1/3 would get changed into 3/9. So 9/9 plus 3/9 gives us 12/9. So then it's 2/9 plus 12/9, which equals 14/9. And you could have left it at that as an improper fraction, or you might have written it as a mixed number, 1 and 5/9. Both are correct. Number 6. 25% of 140, well that's the same as a quarter of 140. So if I halve 140 I get 70, if I halve 70 I get 35. So 25% of 140 is 35. 42 minus 6 times 3. If you said 42 minus 6 first and then multiplied your answer by 3, you're incorrect, I'm afraid. We have to remember the order of operations. So 6 times 3 is actually 18, and then 42 minus 18 is 24. Number 8, 2/7 divided by 4. Well, our answer there is 2/28 or 1/14. So 2/7 divided by 4, we can use the inverse to help us. We know that 4 is the same as 4 over 1, but if we're going to use the inverse to help us, we're going to change that division to multiplication, and instead of it being 4 over 1, we're going to change that to 1 over 4. So 2 times 1 is 1, and 7 times 4, 2 times 1 is 2, not 1, and 7 times 4 is 28, so we get 2 28. And then if you halve both of those numbers, you get 1 over 14. So well done if you got those. Again, as I've been saying all week, any of those that you found really tricky or you think, oh, that's my area to work in, because you'll all have different targets at this point in the year. So just send us an email and we can give you some work to make sure that you perfect that before you leave primary. So we're going to start off with a quick recap on scale factor, what we did yesterday. So looking at the shape on screen, you can see we've got a rectangle labelled A. I'd like you to enlarge this rectangle by a scale factor of 2. So this helps if you have squared paper. And if you haven't got squared paper, then you'll need to make sure that you've drawn, if you've got lined paper, you're going to have to draw vertical lines on it to turn it into squared paper for today's lesson. So enlarge this rectangle by a scale factor of 2. Pause the video here whilst you do that. Excellent. So your new shape should look like this. We can see that A had a length of 3 squares and a width of 1 square. So if we multiply those by 2, we get 6 by 2. So what scale factor has rectangle B been enlarged by? So look at the relationship between A and B. What scale factor has it been enlarged by? Pause the video here and write down your answer. Excellent. It has been enlarged by a scale factor of 3 because shape A, which is a square, is 2 by 2, whereas shape B, which is also a square, is 6 by 6. So to get from 2 to 6, we multiply by 3, so it has been enlarged by a scale factor of 3. These shapes on screen, these triangles, are similar. That means that the sides are in proportion and the angles are the same. You can see here that the pink triangle fits inside the green triangle. The angles are the same, but the sides have doubled. This shape, the larger triangle, has a scale factor of 2. Now, this lady here says all 3 of these rectangles are similar. Do you agree? Pause the video here and write down your reasoning. Brilliant. So, sadly, she is incorrect. They are not all similar. Instead, only the 2 green rectangles are similar. They both have the same angles, right angles, and the dark green rectangle has been enlarged by a scale factor of 2, or the light green one has been enlarged by a scale factor of 2 to create the light green triangle from a length, the dark green triangle from a length of 3 squares to a length of 6 squares, and from a width of 1 square to a width of 2 squares. So we can see the smaller rectangle there was 1 square, had a length of 1 square and a width of 3 squares, whereas the larger green rectangle has a length of 2 and a width of 6. So it has a scale factor there of 2. Whereas if we look at the pink rectangle, although yes, it has the width, it has been enlarged by a scale factor of, or it's been enlarged by multiplying by 2, the length hasn't been enlarged by a scale factor of 2 as well, hasn't been multiplied by 2, so therefore the pink one is not similar to the other 2 rectangles. In each pair of similar shapes, work out the missing lengths of the sides and explain how you calculated them. The first one has been done for you. I'd like you to write your explanation in a similar way. So, here's the first one. We can see we've got a smaller triangle with measurements of 4 centimeters by 5 by 3. Now, the second triangle, which has been enlarged and is similar to the first, is 8 centimeters by 6 centimeters, and we had to find out the missing length. But we can see that to get from 4 to 8, we had to multiply by 2. So it has a scale factor of 2. So now we know that we can use that to help us find the missing measurement. 5 times 2, which gives us 10. So the perfect written explanation would be, in the triangle pair, the missing side length measures 10 centimeters. And I worked this out because I saw that the baseline had been enlarged by a scale factor of 2. Also, the other side was enlarged by a scale factor of 2. So I knew that the missing side length should be twice the length of the small triangle. Therefore, the missing side on the larger triangle is 10 centimeters. So now you've got an example of how to answer that question and how your explanation should be written. Here's another one for you. Looking at the 2 shown on screen, I'd like you to find out the missing lengths and then write down your explanation. Brilliant. So we can see on the first one, the rectangles, one of them has, the smaller one has a length of 2 centimeters and the larger has a length of 6 centimeters. We've multiplied the 2 by 3 to get 6 centimeters. So we do the same with the 3 centimeters width, multiply it by 3 and we get 9 centimeters. For number 2, we can see that the trapezium has a length of 6 centimeters on the enlarged version. So to get from 3 centimeters to 6 centimeters, we had to multiply by 2. So now we could have used that to help us find the missing length, 6 times 2, which gives us 12 centimeters. And hopefully you've all written your explanations in detail, just as I had on the last example. Let's look at another problem together. A family went to enlarge a photograph and buy a frame to fit the photograph. They probably wanted to hang it on the wall, and they didn't want a tiny little picture, they wanted it big, hung up on their wall. So, here are the dimensions for the photograph and the frame. 20 centimeters by 12 centimeters. And the frame is 28 centimeters by 20 centimeters. If they enlarge it by a scale factor of 1.5, what size will the photograph and the frame be? And explain how you worked out the answer. So pause the video here and answer the question. Brilliant. The photograph would measure 30 centimeters by 18 centimeters. The frame would measure 42 centimeters by 30 centimeters. And the way we do that is because if it has been enlarged by a scale factor of 1.5, then we're doing 20 times 1.5. 20 times 1 is 20, and 20 times 0.5 is 10. So whenever you're multiplying a number by 1.5, you're looking at the number itself, and then take half of that number and add it on to the number itself. I've got a little example here I'm going to show you. So if I was doing 24 times 1.5, I'd need to do 24 times 1, which is 24, and then I'd need to do 24 times 0.5, which is the same as half of 24. Half of 24 is 12. Then I take those two numbers and I add them together and I get 36. So 24 times 1.5 is 36. Look at the picture shown on screen. It shows two triangles. There's triangle ACD. So if you go from the letters A, C, and D, you'll see they form a triangle. And triangle ABE. And again, if you do the same, you'll see it forms a triangle. If you go back round to the beginning at the end. Calculate the length of side AD. Show you're working out. So how would you calculate the length of side AD? Pause the video here and give it a go. Excellent. Well, to work out the length of side AD, remember they are similar triangles. So AD is going to have a relationship with the length AE. We know there's no measurement shown for AE, but there is a measurement shown for AB, which is going to be the same as AE, because this is an isosceles triangle. So if this side is 10 centimeters, then that side is also going to be 10 centimeters. If we look at, but that's not all that we need to know. We can see that from 4 centimeters to 8 centimeters, there's a scale factor of 2. It's been doubled. So now we know that AE is also 10 centimeters. We need to multiply that by 2, which gives us 20 centimeters. That's quite a lot to take in, so you might need to pause the video and just have a look at that at your own pace and read the information shown at the bottom of the screen. Excellent. Let's look at another problem. Mrs. Jones has a lawn which has a fence around it. The lawn measures 10 meters by 5 meters. So close your eyes and just picture her lawn, 10 meters by 5 meters. Super. She has a fence all around the lawn. How long is the fence? Show you're working out. So pause the video here and have a go at answering this question. Brilliant. What skills did you need to help you answer this? Yeah, that's right. You were just finding out the perimeter. So her fence is 10 meters times by 2, 20 meters, because we know if it's a rectangle, it's going to be 10 meters on one side and 10 meters on parallel side and on the opposite side, and 5 meters times 2, which is 10 meters. So her fence had to go all the way along the 10-meter side, the 5-meter side, the other 10-meter side, and the other 5-meter side. So her fence is actually 30 meters long. Well done if you managed to get that one. So we're going to continue looking at Mrs. Jones and her lawn. Mrs. Jones decides that she actually wants a larger lawn, so she decides to enlarge it by a scale factor of 3. How much fencing does she now need? Show your working out. So again, pause the video, give it a go before we go through our answers. Brilliant. So if she is going to enlarge it by a scale factor of 3, then we need to do 10 times 3, which gives us 30. And then we multiply that by 2, because we know that it's 30 meters on one side and 30 meters on the opposite side, which gives us 60. Now we're looking at the 5-meter sides. Again, she multiplies that by 3, so 5 meters times 3, which gives us 15, and then 15 times 2, which gives us 30. If we add those together, we get 60 plus 30, which equals 90. So she needs a 90-meter fence. Well done if you managed to get that as well. You might have used a different method, and that is okay. We'd love to see what other methods you used. Mrs. Jones' original lawn measured 10 by 5 meters. How much lawn does she need in meters squared if she enlarged it by a scale factor of 2? So we're thinking about the area here. How much lawn does she need in meters squared if she enlarged it by a scale factor of 2? Well, if she's enlarged it by a scale factor of 2, then she's now got, her lawn is now, instead of being 10 meters, has a width of 10 meters, it now has a width of 20 meters. And instead of a length of 5 meters, it now has a length of 10 meters. So 20 times 10 gives us 200 meters squared. So to calculate the area after enlarging by a scale factor of 2, a simpler way of doing it is to just quadruple the original area. So that's the times by 4. But don't worry if that bit was a bit tricky. You could just simply work out, yep, she's times that. She's done a scale factor of 2, so the 10 becomes 20, the 5 becomes 10, and then multiply them together. And lastly, you were sent a scale factors problems worksheet this morning. So I'd like you to choose the one where you feel most comfortable. Do have a look at all of them. So before you choose and think, oh, I'll just go with number 1, have a look at all of them before you print them and decide which one you're going to have a go. Or even if you're not printing and you're just writing them out, have a look at which one you feel most comfortable with and then decide from there. I've also put in an extra activity, so for those of you who feel super confident and really want to challenge yourself, I put in the mastery questions as well. So do have a go at those if you feel confident enough. And lastly, we want to see all the work that you have been doing. So remember to just take a picture and send that to us at the email address shown on screen. Have a great day. Bye.